Okay, so we're going to start off here with the vocab terms. First term being factor. Had to clarify. This is a verb. When we factor something, we are writing the number as a product of its factors. You are all aware of what the greatest common factor means, but this will come into play here when we talk about factoring these linear expressions. So let's just get right into this and work on this first example where we're finding the greatest common factor of these two terms. You have found greatest common factors before. You know what it is, you know what it means, but you've probably never found the greatest common factor of algebraic terms, which in this case you see we have a coefficient and we have a variable. In one case we have two variables. So I just want to kind of break down the process and show you a couple of different ways, and then I'm curious. Well, actually, I tell you what, why don't we do it this way? We have 25x and 15y. 15xy, sorry. Now let's ignore the variable portion of this for now. Just for now. And I want to know, how do you find the GCF of two numbers? Like if I just put out 25 and 15 and I said, let's find the GCF of that. What do you do? Owen? Okay. So 5 would be the greatest numerical common factor you're thinking. Is that what you're thinking? Okay. Now go back to what you said first. You said try to divide, you said trying to divide by itself. What do you mean by that? Yeah. Exactly. And he brought up a great point. This is something I think we all should do. Find the smaller number, the coefficient here, and see if it goes into the larger number. Okay? Because if it goes into the larger number, then what? You got the GCF, right? So let me just change these numbers for now. Like Owen had said, what if it was 30 and 15? If you look at this and say, well, 15 goes into 30, boom, there's your GCF. It's 15. Okay? There aren't any factors of 15 larger than 15. So if the largest factor of 15 goes into the other number, then you've got yourself a GCF. You don't need to mess around with making long lists or anything like that. That is the very first test that I would recommend. So I agree. That's good, Owen. Go ahead, Riley. Okay? 1, 5, 25. Mm-hmm. The largest one that they share. Exactly. How many of you make a list, kind of like Riley said? Whether you do it on paper or sometimes maybe just in your head, kind of make that list. Okay? That's a good way to do it. So she's saying, yeah, I've got common factors here and here, but you're going to want the larger of those two, so that in this case obviously would be 5. So our GCF is 5. But here's something that we haven't really looked into yet. This one also has a factor of x, whatever x is. This one has a factor of x and y, whatever they are. So not only are you looking for the GCF of the coefficient, you're looking for any variable that they share between them. So our GCF here, guys, isn't just 5. What is it? Garage? 5 and x. It's 5x. The greatest common factor that they both share an x, and 5 would be the other factor. So this is the GCF. That's the new part here with the variable. Okay? The other way, does anybody have a different way of finding GCF? Anybody use like the prime factorization method to do this? You do, Andrew? Can you explain what that looks like? Okay. Yep. Yes. Good. So what would my prime factors be for 25? 5, 5, 1 and x, right? But everything has a 1 in it, right? So he'd have 5, 5, and x. These numbers have to be prime, and they are. Okay? So, Andrew, what would 15 be? Prime, prime, x and y. So now you're looking and finding the GCF between those two, right? Now, there is one small difference that this problem really doesn't highlight. It would be if they shared more than one of those prime factors, okay? And we'll get to that in a minute. But, Andrew, do you know how you would handle that? Like if they both shared, like, not only a 5, but let's say, I know I'm making this up, but let's say they both shared a 3, too. Would the GCF still just be 5? Yeah, so what we're going to end up having here is 5 they share and the 3 they share. So your GCF would actually be 15. 5 times 3. Okay? Well, I'll show you that in a little. I don't want to spend too much time there, but I'll show you that in a minute. Yes, Owen? That's a great question for the group. He says, what if they're all different? What if they don't share anything? Mary? They always share 1. So your GCF is 1, or you would say, in this case, they don't really have any common factors, right? So when we get to that expression where the only thing they share is a 1, we experienced this the other day on Friday with our little lab that we did. What happened? I think the example was, I believe it was 2n minus 3, and we said factor it. And you say, well, 2 and 3, they don't share anything besides 1. You're right. So what was the end result? Remember what we said about this one? AJ? Yeah. Or I said if the only thing you can factor is a 1, then we would say that expression, we'd say it cannot be factored. Okay? Because every pair of numbers shares 1. Like Mary said, shares 1 as a common factor. So that, we're not changing it. AJ said, well, wouldn't that just be 1 minus 3? He's right. But it's the same thing. It's just 2n minus 3. So we can't factor it anymore. Okay? Yes, Rob. Composite? Yeah. All right, let's go down here. Let's bounce down. Let's try a couple of these examples. I'm going to let you guys just dive in and do these 3 here. Just go through, find the 3 GCFs, and then look to your left and right, check with your neighbors, and see what they think. All right, how about letter A? What'd you calculate for your GCF here? Ben, what do you have? 4x. Anybody else get 4x on this one? Good. I'm going to come back to that one in a minute, but let's list these other two. How about B? Sloan? 8s. Do we agree with 8s? Okay, and how about C? Letter C. Sylvie? 6mn. Did anybody else get 6mn? Okay, good. Let's go back up to letter A. And I want to talk about, like, the prime factorization way. If you're struggling to figure this out, this may be something you like to do. It may not be. So you have the choice. But like Andrew had brought up earlier about what you're trying to do, if I'm trying to do a prime factorization for 48, you just want to start breaking it up into prime factors, okay? So for instance, think of 48. I know 2 will go in there, and it's 2 times 24, right? Well, isn't 24 2 times 12? So I'll use that. 12 is 2 times 6, so I need another 2 there. 6 is 2 times 3. So 2 times 2 is 4, times 2 is 8, times 2 is 16. Is 16 times 3 48? Yeah. All of these numbers multiplied together give you 48, and then you have an x. And they're all prime. Likewise, 28 is 4 times 7. I start thinking in factors. Well, 7 is prime, so I know that. And 4 is just 2 and 2, right? And then we have an x. So the point I was trying to make earlier is if you just say, okay, I want to find the greatest common factor, well, you might look and think, oh, well, the largest number that they have in common is 2. So my GCF is 2. But we know it's not 2. We know it's 4x because this 2 could be paired up with this 2. I have another 2 that I could pair up with another 2 on the 20 or on the 48. This one and this one have nothing else to compare to. So if you multiply 2 by 2, that's how you could get a 4. And then, of course, you have your x out here. So this is why I brought that up, because the other example, we didn't have a good, good way of showing that. But that's how you could do that problem. I'm assuming most of you just list the factors anyway. You probably don't do the prime factorization way. You probably just list the factors. All right, let's turn this over. So we'll be able to go through this quickly because we've done this already. When I give you the expression 12x plus 48, and I say factor this, this would be like having 12 green tiles and 48 blue tiles, cubes, and I say, okay, arrange this into a rectangle. This is what you were doing. But after a little while, you guys said, you know what, I don't need to build this. I don't need to take all these cubes and tiles and arrange them into a rectangle because I know what I'm doing here. And you knew that because you were finding a factor. Okay, in this case, the GCF. So what would the GCF of 12x and 48 be? This one is a quick one because it's the first test you should do all the time. Dominic? Not 6. That's a CF. It's just not the GCF. Sam? 12, right? The first test is, does this 12 go into 48? And if the answer is yes, then 12 is your GCF. Okay? So GCF, 12. Now it says use the distributive property to write this expression, which means you're going to have a number outside of a quantity inside of parentheses. Well, the number outside of the quantity would be what? Yeah, right, the GCF. So that's 12. 12 groups of how much? Eta? X plus 4. And now you factored that. You've broken it up into the maximum amount of groups. I can't break this up into any more equal groups than that. Dominic was right. You could have broken this up into 6 groups. You could have broken it up into 4 groups. You could have broken it up into 3 groups or 2 groups. You could break them into different groups. But when we factor, guys, we're in search of the GCF. Okay? So let's just say I would have used the first example that Dominic gave us, because I want to prove this point. I think we all really need to pay attention to this. If I had 6 groups, what would be inside my parentheses here? 6 groups of what? Bryce? Eight. Good. Now, do you guys know, maybe not, do you know how to look at this expression and determine if you've actually fully factored this expression? Because what I've highlighted there will tell you either yes or no. Did I factor it completely or did I not? Anybody know what I'm looking at here? Or what the point of me asking this question would be? Barrage? 2 and 8, they have a common factor. Yeah, exactly. So within your parentheses in that quantity, if they share a common factor, then you did not fully factor this expression. So 2 and 8, Barrage, what's the common factor? Well, 4 doesn't go into 2, though. So it's 2. So if you find yourself in this bind and you're like, oh, no, I didn't factor it because I see another one. Well, if 2 is the common factor here, you could just multiply this factor by 2 to get your GCF and then divide each of those by 2 to come back. Okay? So that's just something to watch out for because I get a lot of people that factor it, but they don't fully factor. All right, go down and try this next one. 6m minus 24. Search for that GCF. What is your GCF? Joey? 6. So I'm going 6 groups of what, Joey? So if I look here and say, okay, my coefficient in front of the n is a 1. I have 1 and I have 4. Well, if one of them is 1, then you know you fully factored it, right? If you factored it down so far that your one coefficient or number is 1, then I know that that's factored, okay? All right, do these 3 here. Try those 3 and check with your neighbors when you get them. Just factor those out. All right, so you check them with somebody, maybe. What do you get for number, well, letter A, rather. Give me the factored form of that. Go ahead, Tommy. Yeah, 4 times the quantity, x plus 7, or 4 groups of x plus 7. Good. How about B? Gracie? Good. 3 groups of 1 plus 11x. Believe it or not, that gets missed a lot just because of I think it's maybe because the x term is second or for whatever reason, but it is. GCF is 3, factor it out. How about C? C, Riley? All right, so what would we say in that case? Yeah, we would use, I'm fine with the abbreviation CBF cannot be factored if you want to write something like that, because it cannot go any further than that. I mean, so we don't have to write one group of this. You can just put that when they do not share any common factors besides 1. All right, great. All right, we're almost here. Take a look at example 6. I've got to make a change here. Example 6 is the area of a square is this. I'm going to change that from the area to perimeter. Perimeter of a square is that. Find the lengths of the sides. Okay? And then 7 is the area of a rectangle, which this is what we were working on with the algebra tiles. So I want some possible lengths there. And then you can try example 8 too. So let's go 6, 7, 8 here. I'll just be walking around. I'll check them out for you when you get them. What's it going to be? Nick? 3x plus 4, I agree. Why is it just 3x plus 4, Nick? What about 2? Couldn't I have done like 2 groups of 6x plus 8? Mathematically, you say, yeah, you could have done that, but why would that not work in this example? Tommy? Yeah, exactly. Every side has to be the same. In order for the perimeter to be 6x plus or 12x plus 16 on a square, all 4 sides have to be that value right there. So you're factoring a 4 out of that because you're looking for 4 equal groups because it's a square, 4 equal sides. So that's what we need there. Here we could have had multiple answers. Actually, I take that back. We couldn't have. Well, if we're going to stick with our integer values here. How did you factor number 7? AJ? 5 groups of 3x plus 2. The only common factor they share besides 1 would have been 5. So that's how that gets factored. So you could say the rectangle has a length of 5 and a width of 3x plus 2, something like that. All right, good. Jump to the example 8. So a group, 5 people are attending a sporting event. They paid $20 to park the car, and total cost of attending the game, 10x plus 20. So here's your expression. So the 10x would represent the ticket cost. The $20 is a one-time fee to park the car. So how much does each person have to pay here? Ada? 2x plus 4. How do you get 2x plus 4, Ada? Good. Okay, so why couldn't I do this? Why couldn't I take this and be like, you know what? They share a 2, so I'm going to go like this. Factored it. So tell me what's wrong with that. Yeah. Yeah, the other 3 people skated and didn't have to pay, right? 2 people paid for this whole thing. That's what that's saying. 2 people would pay 5x plus 10. But what about the other 3 people? They must not have paid anything. So this is assuming that everybody pays the same amount. They would have had to pay 2x plus 4. So just to give you a heads up, if I ask this question when it counted for a grade, and you give me this right here, I'm going to mark this wrong because that is not explaining the answer the way that it needs to be explained. You could say, yeah, it factored it. But that's not what this problem is asking. Everybody's not paying 2x plus 4. Or 5x plus 10, sorry. Everybody is paying 2x plus 4. All right, last one here. Take one of the levels and give those a shot. See where you end up. level 1. GCF is 4. So you're talking about 4 groups. In each group, you would have the quantity 2n minus 7. Number 2, or level 2, Bill's income can be this, can be written as this. What's his weekly income, assuming there's 4 weeks in the month, and assuming he makes the same amount each week? Right, what'd you get for your, how much does he make each week? Barrage? 10x, close. 40 times 4 would be 160, not 120. Bryce? 30, yeah, because you're doing 4 equal groups of that, so he makes 10x plus 30. Now, level 3. You could factor this a couple of ways. Anybody want to share how you factored it? Joey? Anybody do that? I don't think I saw that in any other place. That's good. Give me another way to factor this. Another way to factor this. Jesse? 3 groups of 1/4 x minus 4, you said? Anybody do it that way? Okay. Ben? Anybody do that? Any others? I like them all, right? If you distribute every one of those expressions through every one of those expressions, you're going to come back to get that right there. Excellent. All right, very good.